In the diagram, segment GF is a perpendicular bisector of segment DE. Which statement is not necessarily true? Okay, so remember that the first part of the statement, GF, is actually the perpendicular bisector, and segment DE is the one that's being bisected. And so when it's being bisected, the second part here, DE is actually being cut in half. It's bisected. And also, there's an extra part here that says it's a perpendicular. So GF is a perpendicular bisector, which means that DE is actually going to form right angles. So it's going to form right angles here, 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 and here. Okay. Which statement is not necessarily true? Well, let's go down our options here. DH is congruent to HE. Well, this is true because of the word bisector here. We know that DE is a segment that was cut into two congruent or equal parts at this letter H here. All right, what about the second statement? Angle DHG, DHG is right here, is congruent to angle GHE, GHE is right here. So are these two angles congruent? And they are. They're both right angles. They both measure 90 degrees. What about choice 3 here? Angle FHE is a right angle. Well, FHE is right here. And it also happens to be a right angle. Because we know that if these two are right angles, right, over here we have a line, and the line is 180 degrees. So 180 minus that 90 degree is also going to give us 90 degree. Same thing here, right? Just forms a line. So if one line measures 180 degrees, if we already have 90 degrees here, the other part is also going to be 90 degrees. So we know that all four parts are going to be 90 degrees. And they are right angles. So this is also true. Let's take a look at option 4. GH, so segment GH right here, is equal to segment HF. Is that necessarily true? I don't think so, right? Because there was nothing that said that segment GF was being bisected, that it was being cut in half, right? It only said something about DE being cut into two congruent parts.